Welcome back to another episode of my learning derivatives, where I show you everything there is to know about derivatives, or how all the techniques, the basics. So here we have, we're going to be doing the product rule, Leibniz's notation, and we're going to be deriving inverse functions, inverse trig functions. So here we have a function which will be y equals u multiplied by v. So we have a function multiplied by a function. Therefore, the derivative will be second function multiplied by the derivative of the first, plus the first multiplied by the derivative of the second function. Okay, so let's get into it. So here we have example 1. We're going to say y equals x multiplied by tan negative 1 x. Okay, so we have our y equals u multiplied by v. So we're going to, the derivative, let's write out the derivative. Derivative will equal v multiplied by the derivative of u plus u multiplied by the derivative of v. Okay, that was a bit of effort. Okay, so what do we need to know? We need to know v, u, the derivative of u, and the derivative of v. Okay, so let's write that out. Well, we'll say that v, up here, we'll say that v is tan inverse tan x, and we'll say that u is equal to x. Okay, so the derivative of v, what's the derivative of the inverse of tan x? 1 over 1 plus x squared. And what is the derivative of u? With u is x, the derivative is 1. Okay? So now we have all we need to answer the question. Let's answer the question. Okay. So the derivative, v. We said that v was tan inverse x multiplied by the derivative of u, which is 1, plus u, which we said was x, multiplied by the derivative of v, which is 1 over 1 plus x squared. Okay, now we have this, we can solve. Inverse of tan x multiplied by 1 is inverse of tan x, plus x on 1 plus x squared, because all we're doing is multiplying the x on top. Okay, now that's the question answered. If you wanted to write it a different way, you could write it, just replace the inverse of tan x with arc tan x. This here equals the exact same as that. Inverse of tan x is the same as arc tan x. Okay? Now, we're going to go straight into our second example. Y equals e to the x multiplied by arc sec x. Okay. So we need a u and we need a v. if we're going to use the product rule to solve. Okay, so like before, I'm going to write out the derivative. So it's going to be, if I can get the right colors, v multiplied by, I'm just going to use this, derivative of u plus u multiplied by the derivative of v. Okay, so what do we need? We need v. We need a derivative of v. We need a u. We need a derivative of u. Okay, so we'll say that v is arc sec x. Okay, and the derivative of arc sec x is 1 over x square root x squared minus 1. It's a bad x, but hopefully you understand. And u, well, we'll say u is e to the power of x. And the derivative of e to the power of x is e to the power of x. Nothing changes. Okay, well now we've got all these, let's fill it out. Okay, so it says the derivative of y with respect to x is equal to v. We said v was arc sec x multiplied by the derivative of u multiplied by e to the x plus u, which is e to the x, multiplied by the derivative of v with respect to x, which is this 1 over x square root of x squared minus 1. Not much to complete now. Instead of multiplying this on top of the fraction, because we have an e to the x multiplied by this as well, I'm going to factor the e to the x, both of them out the front. And what we're left with is arc sec x plus 1 over x square root of x squared minus 1, all multiplied by e to the x. Okay, and that there is your derivative. Thanks for watching. I hope you learnt something and have a good day.